Hi, everyone. I'm really happy to be here. My name is Tatiana. And today, I'll also talk to you about AI safety. I'll tell you about SynthID, a method to identify AI-generated text by watermarking your language model. So why should you watermark your language model? Generative AI is everywhere around us, and it is really fun to create content with it. However, it can really increase the scale of misinformation that we find online. It has become more and more difficult to determine the origin of content that we find online, and as a result, deepfakes and fake news are becoming more and more common. To solve this problem, Google has introduced SynthID. It's a suite of tools which can be used to detect AI-generated content: audio, video, images, and text. And today, I am really happy to tell you about SynthID Text, a method that we open-sourced last year in HuggingFace, so that you can use it on your own models, and on Gemma models too. So why should you watermark your text? Imagine you built a language model, and you're hosting that model behind an API. Users can access that model and post the content online. Now, if you enabled watermarking with your model, you will be able to determine for content that you find online whether it was generated by your model or it wasn't. This is because watermarking embeds a digital signature in the text that your model generates, and thanks to this, you can recognize the watermark. You don't have to retrain your language model because the watermarking is placed on top of it. You also need a watermarking key to be able to detect the watermark. This means that you can keep the information private to yourself, or you can share it with others. In this next section, I will tell you more details about how we developed the SynthID text method. We had several design decisions that we made. First of all, the watermark has to be detectable. We have to be able to detect it with high accuracy. Second of all, it cannot degrade the quality of the text that your language model generates, because users would not be happy about it and they would not accept it. Third, it has to be robust to small modifications of the text. It shouldn't be easy to remove the watermark from the generated text. Finally, the method has to be lightweight. There is no need to retrain the model, and there is no significant latency requirement. When you generate language from a language model, the first step is the language model gives you a distribution of all the possible next tokens. What you do next, you sample one token out of all these tokens. In this case, is the token mango. Here is what we do with watermarking instead. We combine the most recent context that the model has seen. In this case, is the 3 tokens tropical fruit is, and we combine that with the watermarking key to generate the random seed. Now we pass that random seed to the watermarking function, and we obtain the watermark value 1 or 0 for each of the possible tokens. Now, instead of sampling just 1 token from the model's distribution, we sample 2, and we have a tournament. We look at the watermark values of these 2 tokens, and we pick the one with the higher value. In practice, we have multiple tournament layers on top of each other, because that increases the robustness of the watermarking method. Because the model prioritizes n-grams with watermark value 1, we modify the distribution slightly to prefer these n-grams. And so when we want to detect whether a text is watermarked, we calculate the watermark values for each n-gram in that text. We are left with a sequence of watermark values, and we check if there are about equally many ones and zeros. if there are, we can conclude that there is no watermark in the text. However, if there are significantly more ones than zeros, we can conclude that the text is watermarked, and it was generated by this particular model. As I said previously, it is really important not to degrade the quality. And we show this theoretically and empirically in multiple ways. First, we looked at the standard benchmarks, and we found that there was no significant difference between a watermarked and unwatermarked model in their performance. Second, we asked people if they preferred the watermarked or unwatermarked response, and we found that there was no difference in their preference. In the final section, I would like to tell you how you can use SynthID text in HuggingFace and how easy it is to set up. You can start by configuring your watermarking method. In this part, it is really important to specify your own sequence of watermarking keys and keep them secret. The second step, you pass the watermarking config to model generate. And that's it. You only need a few lines to be able to generate watermark text. I would encourage you to do this yourself so that you can really convince yourself that watermarking doesn't affect the quality of the resulting text. Now, to detect the watermark, you need to prepare watermarking detector. You do this by first gathering a corpus of watermarked and unwatermarked text and training a Bayesian detector. We posted a really detailed example online on how you can do this, so it is very easy to do. Finally, you pass the text that you're curious about to the watermark detector, which tells you whether the text is watermarked. And that's it. If you would like to learn more details about the method and how it works, please take a look at our paper. And if you want to know more on how to use the HuggingFace implementation, take a look at our blog post. I would like to acknowledge the amazing team that has delivered this method. And finally, I would like to thank you for your attention.